To session 6 of physics. Today we are going to study few various important topics. The very first topic we are going to study is different types of variables. Different types of variables and constants. We are going to study different types of variables and constants. The very first, that is dimensional variables. Dimensional variables. What are dimensional variables? The physical quantities which possess dimensions, the quantity which are having dimensions and have variable values are called dimensional variables. See, a basic concept over here is the physical quantities which possess dimensions. Mean they have dimensional formula. They have powers of m, l, and t, and they have values variable. Variable means the value changes every time. Such quantities are known as dimensional variables. Clear? Examples I can give you over here. Examples means area, volume, velocity, force, etc. Hope till this clear. Second quantity that is we are going to study is dimensionless variables. The physical quantity which are dimensionless but their values are variable are called dimensionless variables. The physical quantity which have no dimensions means there is no MLT formula for them but have variable values are called dimensionless variables. Clear? Example I can give over here is angle. We have seen that it's M0, L0, T0, but angles may have value. So angle, specific gravity, strain, change in dimension upon original dimension that we have seen is against dimensional parallel but having some values. Till this clear? Moving ahead with the third quantity, that is dimensional constants. Clear? The physical quantities which possess dimensions means which have dimensions and have constant values means their value is not changing every time and have constant values are called dimensional constants. Example I can give you. Gravitational constant, everybody knows value of G, which have unit also and which have constant value. It does not change anywhere. Gravitational constant, I can say capital G. Planck's constant that already discussed, that is H. Planck's constant H, we can say. Moving to the next quantity, that is dimensionless constant. Dimensionless constants which does not have dimensions but they have fixed value. Such quantities are known as dimensionless constants. The constant quantities having no dimensions are called dimensionless constants. Till this clear? Example I can give you: pi, exponential e, etc. Moving to the next topic, that is applications of dimensional analysis. Application of dimensional analysis. Moving to dimensional application, the very first application of this dimensional is, you can write the method. I am specifying in general first. The method of studying a physical phenomena on the basis of dimensions. If you are studying any physical quantity on the basis of dimension, means MLT, is called dimensional analysis. There are three basically applications. Following are the three main uses of dimensional analysis. The very first point in dimensional analysis to convert, we are able to convert from one system of unit to another very easily with the help of dimensional analysis. To convert a physical quantity from one system of units to another. Clear? Conveniently we can convert the value from one system of unit to another. Second, to check the correctness, whether the given equation is correct or not. To check the correctness of a given physical relation. If I give you the equation, we will be able to check whether this equation is correct or not with the help of what? Dimensional analysis. Third point, to derive a relationship between different physical quantities. We can derive relationship between different physical quantities. These are the main three uses of dimensional analysis. Hope it is cleared. Moving to the next topic, that is conversion of one system of units. How to convert one system of units into another, we'll see by example. Conversion of one system of units to another. It is based on the fact that the magnitude of a physical quantity magnitude of a physical quantity remains the same. What does this mean? I can give you an example. 5 centimeter is equal to 0.05 meter is one and the same. If I give 5 meter, if I say 5 meter which is equal to what? 500 centimeter, is both are same? Yes or no? So you can take any physical quantity which will have different magnitudes in case of what? Different system of units, but the value remains what? Same. Okay, fine. Now we can say that whatever may be the system of units, the magnitude of a physical quantity remains the same if U1, and we have represented in the places of measurement that for Q is equal to what? NU, where N stands to what? Magnitude, and U stands for what? Unit. We have discussed measurement of a physical quantity is represented by Q. Measurement of physical quantity that was represented by Q is equal to NE. If U1 and U2, I am taking two units, are the units of measurement of a physical quantity Q, physical quantity Q, and N1 and N2 are the corresponding numerical values, then Q is equal to N1 U1, that is equal to N2 U2. See why I have taken N1 U1 is equal to N2 U2? Because the magnitude of both this physical quantity, the magnitude of the physical quantity is going to remain same in both the units. Yes or no? N1 U1 represents one system of units, N2 U2 represents second system of units, but magnitude remains same. Again I have given you example in the previous, that is was 5 meter is equal to 500 centimeter. Was 5 meter is equal to 500 centimeter, we can see the magnitudes are different, 500, but system of units are also different, but the value remains what? Same. The meaning to be conveyed is same. So moving ahead, let M1, L1 and T1, M1, L1 and T1 be the sizes of fundamental units, of mass, length and time in one system, you can say, in one system. Similarly, M2, L2 and T2 will be in the second system, and M2, L2, T2 be the corresponding units in another system. If the dimensional formula of any one quantity, we can assume if dimensional formula of quantity Q can be expressed as M raised to A, L raised to B and T raised to C, then for the first system of units it will be what? M1, L1, T1. Yes or no? And for the second system of unit U2, for the first system of unit you can write M1 raised to A, L1 raised to B, T1 raised to C, and for the other system of unit you can write M2, you have taken for mass M2, length L2 and time T2. Clear? I can express in terms of Q is equal to Na. So first magnitude was N1. A unit for the first term is what? M1 raised to A, L1 raised to B, T1 raised to C. Magnitude for second system of unit is N2. Dimension formula is M2 raised to L, L2 raised to B, T2 raised to C. Till this clear? I want to determine N2, therefore N2 is equal to N1. This will come down. Yes or no? So I can write M1 raised to A, L1 raised to B, T1 raised to C divided by M2 raised to A, L2 raised to B, T2 raised to C. I can write in the terms of what? I can write in terms of mass, so m1, m2, yes or no, whole power a, l1, l2 whole power b, t1 by t2 whole power c. Yes, this equation can be used to find the numerical value in the second or new system of units. This is how you can find the value of physical quantity in another system of units. We'll take one example over here in order to make it clear, more clear. The example over here, let us convert. I'm taking one example. Let us convert 1 joule into erg. Remember, joule, SI, erg, or you can say MKS, erg, CGS. Clear? You have to convert joule into erg over here. The very first step, energy dimensional formula, because joule unit is energy dimensional formula is m1 l2 t minus 2, that everybody knows. Yes or no? Here if you are going to compare it with m raised to a, l raised to b, t raised to c, what is power of m? A is equal to 1, I can say. B is equal to 2, I can say. C is equal to minus 2, I can say. Yes or no? Now start making comparison. SI versus we are going to convert it into CG. S for N1, you can say they have mentioned 1 joule, so N1 is 1. N2 I have to calculate in CGS, so it's dash, question mark I can put, and I have to calculate in erg. Yes or no? M1 in SI 1 kg. Yes or no? 1 kg. 1 kg is how many grams? 1000 grams. Yes or no? 1 kg represented what? 1000 grams. Here M2 you can say 1 gram. Yes or no? L1, that is 1 meter, you can put how much? 100 centimeter. Here L2 will be what? 1 centimeter. Yes or no? One more thing you are pending over here, that is what? T1. T1 is what? 1 second. In CGS also time never change, so T2 is equal to what? 1 seconds. Till this clear? Now we can put the formula. N2 that is equal to what? N1. We already derived M1 by M2 raised to A, L1 by L2 raised to B, T1 by T2 raised to C. That we have already derived. Now we can put 1. N1 was 1 with us. M1 that was 1000. M2 was 1. A was 1. L1 was 100. L2 was 1. It was what? Minus 2 or 2. For T1 it was 1. T2 was 1. It was minus 2. So 1000 raised to 1 is going to be 1000. 100 square is going to be what? 1, 2, 3, 4. And 1 raised to any power or plus minus is going to be what? 1 only. So this I can write as 10 power 3. This I can write as 10 power 4 because 4 zeros. 10, both base are same, so I can add the powers. So my answer is how much? 10 power 7. Unit will be what? Erg. Clear? Here you have to keep one thing, remember in your mind, that in whichever quantity you have to convert, in whichever the unit system you have to convert, you have to take that system to be, all the parameters to be 1, 1, 1. Here we have to convert MKS, that is in SI, into CGS. So I have taken in CGS all ones. Mass also 1, length also 1, time also 1. So whatever physical quantity is being converted into the newer system, that system in which we are going to convert, that system parameters we have to take what? 1. Clear? Clear? Okay. Moving to the next example. See, The question we are provided over here is the value of G in CGS system is 6.6 into 10 power 6.6 into 10 power minus 8. Unit is Dian centimeter square gram minus 2. Calculate the value in SI unit. Now very first of all, whatever quantity is given, you should know dimensional formula for the same. The value of G, dimensional formula of this G is M minus 1 L3 T minus 2. But if somebody said, sir, I forgot the value of G, now how to derive? We know that universal gravitational law F is equal to what? G m1 m2 divided by r square. From this I can calculate G. For the G, that is what? F r square divided by m1 m2. Now force I know what? M1 L2 T minus 2. L2 or L1? L1. Very good. N2 r square is what? L2, and m1 and m2, that is m, and this is one more m, I can say. So my answer is m1, and this is 2, so it will be minus 1. L1 and 2, that is going to be 3, and T is only minus 2 to minus 2. See, you can see that I have matched the value of G. If you can remember the value directly, it's well and good. If you're not able to remember the value, you can derive it by using the law or a physical relationship that is governing that value, that physical quantity. Clear? Okay, fine. Now you can see, comparing this, you can get A is equal to minus 1, B is equal to 3, and C is equal to minus 2. That also you got. Now make a table SI versus CGS. Clear? Now N1, where they have already given, in CGS they have given. CGS they have given means N2 they have given already. Yes or no? So N2 they have given, that is how much? 6.67 into 10 power minus 8. Till this clear? Now M2 you will take 1 gram. I take 1 gram. Then next is L2, that are going to take 1 centimeter, and T2 that you are going to take 1 second. Till this cleared? Now N1 I have to derive. Second, M1 L1 T1. M1, that is 1 meter. M1, that is 1 kg mass. So 1 kg we have to, CGS given, so we have to convert it into CG, that is 1000 grams. Next 1 meter, that is 100 centimeter, and 1 second is going to be 1 second only, it's not going to be converted into anything. Till this clear? Now we have formula. We was having formula is what? N2, that is equal to N2, that is equal to, we were having formula, remember, N2 that is equal to, here you will be able to see that we are having N2 with us, but we are not having N1. So for finding N1, I have kept N2 this side, N1 this side. So this will move this side. So it will be reciprocate M2 by M1 raised to A, L2 by L1 upon raised to B, and T2 by T1 raised to C. Now moving ahead. So I have got the final formula to be, I have to determine N1, that is equal to N2, M2 by M1 raised to A, L2 by L1 raised to B, T2 by T1 raised to C. N2 I am having 6.67 into 10 power minus 8 with me. M2 I am having 1. This is I am having 1000 with me. A is minus 1. Here I can say that this is 1, this is 100. Power is 3. And C 1 raised to power is how much? Do you remember? Minus 2. Is this clear? 6.67 into 10 power minus 8 I can keep. I can write 10 power 3 minus 1. I can write 10 power 2, 3, 1 minus 2. 6.67 into 10 power minus 8. If 10 will move up, power will become negative. Outside is minus 1. Power will move up, so it will be minus 2. Power plus 3. 1 raised to minus 2. 6.67 into 10 power minus 8. Minus 3 into minus 1 is going to be what? Plus 3. Minus 2 into 3 is going to be minus 6. And anything is going to be what? 1. So 6.67 into 10 power minus 8 into 10 power 3 into 10 power minus 6. 6.67. 10 power minus 8 as such. Minus 6 plus 3 is minus 3. So 6.67 into 10 power minus 8 minus 3 is what? Minus 11. Till this clear? So in SI system you can say that in SI system the value of G is found to be 6.67 into 10 power minus 11 Newton meter square upon kg square. Hope it is cleared. Now we are having example in which they have find the value of 60 joule per minute. They have mentioned 60 joule per minute and on a system that has 100 gram, 100 centimeter and 1 minute as base units. See here there is no specific condition given about the system of units, either SI to CGS or CGS to SI. Nothing is mentioned. They have given some basic units, that is 100 gram, 100 centimeter and 1 minute. You have to use these and you have to get the answer. Clear? Now moving, let us check what is the quantity first given. 60 joule per minute they have asked. Yes or no? So 60 joule is okay. Joule is standard unit. Minute cannot be considered. 1 minute is how much? 60 seconds. 60 cut. So answer is what? 1. So I can write it's 1 joule per second, or I can say 1 joule per second is known as what? 1 watt. Till this clear? Now power dimensional formula. Everybody knows what is dimensional formula for power. Dimensional formula for power is M1 L2 T minus 3. So I can compare A1 B2 C minus 3. Till this clear? Now we can check SI versus there is some new system. I don't know which type of system they have given. I have to determine that there is N2 question mark in that system. M2 they have given me the things that has to be chosen, that is 100 gram. L2 I have to take 100 centimeter. T2 that I have to take 1 minute. See, minute is not standard and I have to convert it into seconds. SI magnitude they have given 1, so I will put 1. For the case of M1, I know that 1 kg, but I can see that unit is in grams, so I will convert it into grams. L2 I know that is 1 meter, but in CGS it's 100 centimeter, and T2 that is 1 second, already in second. This was not in second, I converted into second. Till this clear? Now formula for N2 we are having already know formula for N2. N2 is equal to what? N1 into bracket M1 by M2 raised to A, L1 by L2 raised to B, T1 by T2 raised to C. Till this clear? So substituting value, what you are going to get? N2 that is equal to N1 that is was 1, M1 that we are having 1000 divided by you are having 100 raised to A was 1. Here you can put 100 by 100 raised to 2 and 1 by 1 raised to 60. We have converted into 60 raised to minus 3. Clear? So 1 as such. Clear? 2 zeros are going to cancel, so it's 10 raised to 1. 100 cancel is 1 raised 1 square, and less 60 they have given 1 upon 60 raised to minus 3. Clear? Now what about 1 raised upon 60? You have to check and calculate what is 1 upon 60. 1 divided by 60 more you can say. See, for here you can substitute like this. 1 by 6 you made it separate, and 1 by 10 like this raised to minus 3. Is clear? So 1 minus 10, 1 by 6 you have to check how much it leads to. More specifically, and I can write that this is 1 upon 60 raised to minus 3 only you can keep. 10 into, see what I'll do, this guy I can write 60 raised to minus 1, because if this is power 1 will move up minus 1. So 100 into what? 60 raised to minus 1 into minus 3 is 3. So 10 into 60 into 60 into 60 you can say. Clear or not? 10 into 60 into 60. You can check in the calculator. 60 into 60 into 60 into 10. What you are going to get? 2 1 6 1 0 2 3 4 zeros you are going to get. Now shift the point 1 2 3 4 5 6. I am shifting 6 points on the left. 2.16 on the left means how much? Plus 6. Unit will be what? New units of power. New units of power. You can get the value of what? N2. This is the required value of N2. Hope it is cleared. Thank you so much for the session. We'll see few more topics in the next session.